On the morning of April 16th, 1942, John S. Bugas stood in an empty field in Wayne County, Michigan, watching surveyors drive stakes into farmland that would soon become the largest tank manufacturing facility in human history. Bugas was 33 years old, former FBI agent, newly appointed Ford Motor Company security chief, and at that moment, he was overseeing the first phase of a project that every armor expert in the United States Army said would fail spectacularly. Ford Motor Company had committed to building tanks using automotive mass production methods, the same techniques that built Model T Fords and B-24 Liberators. The Army Ordnance Department was skeptical. Tank manufacturers were skeptical. Even some Ford engineers were skeptical. Tanks weren't cars. They weren't even bombers. A medium tank weighed 30 tons, carried a 75mm cannon, required precision armor welding, complex transmission systems, and tolerances measured in thousandths of an inch. Every tank expert in America knew you couldn't build them on an assembly line. Ford was going to prove them wrong. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The previous year, Charles Sorensen had shocked the aviation industry by building B-24 bombers at automotive production rates, one bomber every 63 minutes at peak production. That achievement had made headlines, won government contracts, and established Ford as the company that could mass produce anything. But bombers were aluminum and rivets, tanks were hardened steel and welds, different materials, different processes, different engineering challenges entirely. The Army needed tanks desperately. In December 1941, Japan had attacked Pearl Harbor. Germany had declared war on the United States. American forces were fighting in North Africa with obsolete equipment against German Panzers that outgunned and outmaneuvered everything the United States could field. The M3 Grant tank, America's best available medium tank in early 1942, was a compromised design rushed into production because nothing better existed. It mounted a 75mm gun in a hull sponson instead of a rotating turret, a design flaw that limited tactical flexibility. The M4 Sherman was supposed to fix that problem. Designed in early 1941, the Sherman mounted its 75mm gun in a fully rotating turret, giving tank crews the ability to engage targets without exposing the entire vehicle. It had better armor than the M3, better mobility, better crew ergonomics. On paper, the Sherman was exactly what the Army needed. In reality, the Sherman didn't exist yet except as prototypes. Production was scheduled to begin at multiple facilities across the United States. Lima Locomotive Works in Ohio, Pacific Car and Foundry in Washington, Pressed Steel Car Company in Pennsylvania, Fisher Body Division of General Motors in Michigan, American Locomotive Company in New York, Pullman Standard in Illinois, Baldwin Locomotive Works in Pennsylvania. Each manufacturer was building Shermans using traditional methods. Skilled workers assembled each tank individually, custom-fitting parts, hand-finishing components, working at speeds measured in weeks per vehicle. The Army's initial production targets called for 500 Shermans per month across all manufacturers combined. That was September 1941 planning. By April 1942, after Pearl Harbor, after the Philippines fell, after American forces in North Africa discovered that German Panzers could kill M3 Grants from ranges where American guns couldn't effectively return fire, the Army wanted more tanks, many more tanks. General Devers, chief of the armored force, told the War Production Board that the United States needed to produce at least 2,000 medium tanks per month to equip armored divisions, replace combat losses, and supply allied nations. At current production rates, achieving 2,000 tanks per month was impossible. The existing manufacturers couldn't expand fast enough. Their methods didn't scale. You couldn't just hire more welders and buy more steel and expect production to double. Tank manufacturing required specialized skills that took months to learn. It required precision tooling that took months to build. It required quality control that couldn't be rushed without producing defective vehicles that would fail in combat. Ford Motor Company believed there was another way. In February 1942, Edsel Ford and Charles Sorensen had met with Army Ordnance officials to discuss tank production. The meeting hadn't gone well. Ordnance representatives explained that Ford could manufacture tank components, ship them to established tank manufacturers for final assembly. Standard procurement approach, the same approach initially proposed for B-24 bombers before Willow Run, proved assembly line production worked. Sorensen listened to their proposal, then said Ford would build complete tanks on a moving assembly line. The ordnance officials said that was impossible. Tanks required too much precision. The armor, welding alone, demanded skills that automotive workers didn't have. The final drive assemblies, the transmissions, the gun mounts, all of it required experienced tank builders. You couldn't train automotive workers to build tanks in a few weeks. Sorensen asked them a direct question: how many tanks per month could traditional methods produce? They didn't have a good answer. Current production across all manufacturers was running around 300 complete M4 Shermans per month. Maybe that could be increased to 500 by summer, maybe 700 by the end of the year, if everything went perfectly. Sorensen said Ford would build more than that from one plant. The Ordnance Department filed reports saying Sorensen didn't understand armor manufacturing, would waste government money, would produce defective tanks that couldn't fight. But the War Production Board was desperate. The United States was losing the war in April 1942. Losing in the Philippines, losing in the Pacific, barely holding in North Africa. The Soviet Union was screaming for tanks under Lend-Lease. Britain needed tanks. America's own armored divisions needed tanks. Traditional manufacturing couldn't meet demand, so the government gave Ford a contract. Build M4A3 Sherman tanks using whatever methods Ford thought would work. The Army would provide specifications, technical drawings, quality inspectors. Ford would provide the plant, the workers, and the production methods. If it worked, the United States got the tanks it desperately needed. If it failed, Ford Motor Company would be blamed for wasting resources during wartime. The site chosen for the plant was in Highland Park Township, Wayne County, Michigan. Not the same location as Ford's famous Highland Park plant where the Model T had been produced, but nearby. The land was relatively flat farmland, good for construction, close to Ford's River Rouge complex for parts supply, accessible by railroad. Bugas watched the surveyors mark out the foundation boundaries. The main building would measure 960 feet long, 559 feet wide, not as massive as Willow Run, but large enough to contain a complete tank assembly line with all supporting operations. Construction began immediately. Multiple contractors working simultaneously. The building went up in sections. Steel framework erected first, then walls, then roof, then interior infrastructure, electrical systems, water, compressed air, overhead cranes, everything needed to operate a precision manufacturing facility. While construction continued, Ford engineers were solving the fundamental problem. How do you mass-produce a 30-ton armored fighting vehicle? They started by studying existing Sherman production. Ford sent teams to observe operations at other manufacturers. What they saw was craft-based assembly. Each tank started as separate components. Hull sections were cut from steel plate, welded together by skilled welders working individually. Turrets were formed, welded, machined. Final drive housings were cast, machined, fitted. Suspensions were assembled piece by piece. Everything came together in one location where skilled workers gradually turned piles of parts into a complete tank. The process worked, but it was slow. A skilled welder could complete maybe 10 feet of quality armor, weld per hour. An M4 Sherman required hundreds of feet of welding. Multiple welders working on one tank for days. The turret alone took 40 hours of welding time. The hull took even longer. Quality control was constant inspection. Every weld had to be perfect. Armor welds that failed would crack under combat stress, letting shell fragments penetrate, killing the crew. Ford engineers saw the same problem Sorensen had seen at Consolidated Aircraft in 1941. Move the product, not the workers. Break the tank into sub-assemblies. Build each sub-assembly on its own specialized line. Feed them to a main assembly line at precise intervals. The difference was that tanks were heavier than bombers, required different materials, different processes, entirely different tooling. The welding problem was the biggest challenge. Traditional armor welding used manual electric arc welding. A skilled welder struck an arc between an electrode and the metal, moved the electrode along the joint at precisely the correct speed and angle, maintaining exact arc length and proper heat input. Too slow and the metal warped from excessive heat. Too fast and the weld didn't penetrate properly. Perfect technique required years of experience. Ford didn't have years to train welders. They had months. So, Ford engineers designed automated welding fixtures. The hull sides would be positioned in precision jigs. Automatic welding machines would travel along the seams at controlled speeds, maintaining perfect arc length, depositing weld metal at consistent rates. One operator could run multiple machines simultaneously. The welds would be identical every time. Perfect penetration, minimal distortion, no human variability. The Army Ordnance Department said automated welding wouldn't work for armor plate. The steel was too thick, the joints too critical, the quality requirements too demanding. Only skilled manual welders could produce armor welds that would survive combat. Ford built the equipment anyway, tested it, refined it, proved it worked. By summer 1942, Ford's automated welding systems were producing armor welds that met or exceeded Army specifications. The turret presented different challenges. The Sherman turret was a complex curved casting that required precision machining. The gun mount had to be perfectly aligned. The turret ring had to rotate smoothly under combat conditions while maintaining armor protection. Vision ports, hatches, radio antennas, all had to be installed correctly. Traditional manufacturers built each turret individually, hand-fitting components, adjusting clearances, testing rotation, making small modifications until everything worked. Ford designed dedicated turret assembly stations. Each station performed specific operations. Station 1 installed the gun mount. Station 2 fitted the recoil mechanism. Station 3 installed vision blocks. Station 4 mounted the radio. Station 5 installed hatches and external fittings. Station 6 tested rotation and made final adjustments. Turrets moved from station to station on overhead conveyors. Workers became specialists in their specific operation, performing the same tasks repeatedly, achieving speed and precision that generalists couldn't match. The suspension system was equally complex. The M4 Sherman used vertical, volute, spring suspension, known as VVSS. Each side of the tank had 3 bogie assemblies, each bogie containing 2 road wheels, springs, and a complex linkage system. The suspension had to support 30 tons while allowing the tank to traverse rough terrain at speeds up to 25 miles per hour. Every component had to be precisely manufactured and correctly assembled. Ford created a dedicated suspension assembly line. Bogie assemblies were built at individual workstations, tested for proper spring tension and wheel alignment, then moved to the main assembly line for installation on the hull. The process was systematic, repeatable, fast. What took traditional manufacturers hours per suspension unit took Ford minutes. The transmission and final drive were perhaps the most challenging components. The Sherman's powertrain consisted of a radial aircraft engine, a synchronized transmission, a differential, and 2 final drive assemblies that delivered power to the tracks. Every gear had to mesh perfectly. Every bearing had to be properly aligned. Any error in assembly would cause the transmission to fail under the stress of combat operations. Traditional tank manufacturers assembled powertrains using highly skilled mechanics who understood the complex interactions between components. These mechanics could feel when something wasn't quite right, could hear unusual noises that indicated misalignment, could make subtle adjustments that technical drawings didn't specify. This expertise took years to develop. Ford couldn't wait years. They designed assembly fixtures that eliminated the guesswork. Gears were installed in precise sequences using special tooling that ensured correct alignment. Bearing clearances were set using calibrated fixtures instead of experienced mechanics' judgment. Every transmission was assembled identically, following procedures that less experienced workers could execute correctly. Then every transmission was tested, not sample testing. Every single transmission. Ford built transmission test stands where completed units were run under load for extended periods. Any transmission that didn't meet specifications was disassembled, inspected, corrected, and retested. Only transmissions that passed testing went into tanks. This approach was expensive, time-consuming, and completely contrary to how traditional manufacturers operated. It also worked. By September 1942, the Highland Park tank plant was nearly ready for production. The building was complete. The assembly line was installed. The specialized tooling was in place. Workers had been hired and trained. The first hull sections were being welded. The Army sent inspectors to evaluate the facility before authorizing full production. They arrived expecting to find problems, reasons to delay, evidence that automotive mass production methods wouldn't work for tanks. What they found was a facility that didn't look like any tank plant they'd ever seen. The assembly line was a moving track that carried hull sections through multiple workstations. At each station, workers or automated equipment performed specific operations: install the floor, install the firewall, install ammunition racks, install fuel tanks, install engine mounts. Each operation precisely sequenced, precisely timed, precisely executed. The inspectors watched hull sections moving steadily down the line, watched workers installing components with automotive efficiency, watched quality inspectors checking every operation. They watched turrets being assembled at dedicated stations, watched suspensions being built and tested, watched transmissions being run through qualification procedures. The plant didn't look like a tank factory. It looked like an automobile factory that happened to be building tanks. The first complete M4A3 rolled off the Highland Park line on October 20th, 1942. It had taken approximately 6 months from groundbreaking to first production unit. The tank was shipped to Aberdeen Proving Ground in Maryland for testing. Army testers put it through qualification trials, drove it over rough terrain, fired the main gun, stressed the suspension, tested the transmission under load, evaluated armor welds under stress. The tank passed every test. The armor welds were perfect. The transmission operated smoothly. The suspension handled rough terrain without failure. The gun mount maintained accuracy. Every system functioned exactly as specified. The Army couldn't find anything wrong with it. More importantly, they couldn't tell the difference between Ford's mass-produced tank and tanks built by traditional manufacturers using craft methods. The Army authorized full production. Ford was cleared to build M4A3 Shermans at whatever rate the assembly line could sustain. What happened next would change how the United States Army understood industrial warfare. Production climbed steadily. 14 tanks in November 1942, 35 in December, 71 in January 1943. The numbers told the story. The assembly line was working. The automated welding was working. The specialized tooling was working. Workers who 6 months earlier had been building cars were now building tanks that met every Army specification. But Ford wasn't satisfied with 71 tanks per month. That was better than most traditional manufacturers, but it wasn't mass production. Charles Sorensen's vision for tank production was the same as his vision for bomber production: 1 unit per hour, 24 hours per day, 7 days a week. For tanks, that meant 720 tanks per month from one plant, more than all existing manufacturers combined. The engineering challenges were immense. Unlike bombers, which were relatively fragile aluminum structures that could be lifted by overhead cranes, tanks weighed 30 tons. You couldn't just pick them up and move them around the factory. The assembly line had to be designed to handle enormous weight while maintaining precision positioning for assembly operations. Ford engineers designed a rail-based transfer system. Hull sections sat on heavy-duty carriages that rolled on steel rails, embedded in the factory floor. The carriages were pulled by electric winches, moving at controlled speeds from station to station. At each station, the carriage locked into precise position, allowing workers to perform assembly operations while the hull remained stationary. Then, when operations were complete, the carriage unlocked and moved to the next station. The system worked, but it was slower than Ford wanted. The carriages took time to position and lock, time to unlock and transfer. Every minute spent positioning was a minute not spent assembling. Ford engineers refined the system continuously. Better locks, faster transfers, more precise positioning mechanisms. Each improvement saved seconds. Multiply those seconds by hundreds of operations across the entire assembly line, and the time savings became massive. By spring 1943, production was accelerating dramatically. 120 tanks in February, 203 in March, 317 in April. The Highland Park plant was approaching the capacity that Army Ordnance had said was impossible for automotive mass production methods. Other tank manufacturers watched Ford's numbers with disbelief. How were automotive workers building tanks faster than experienced armor manufacturers? The answer was systematic process improvement. Ford engineers analyzed every operation, identified bottlenecks, eliminated inefficiencies. They discovered that turret installation was slowing the line. The turrets were heavy, approximately 10,000 pounds, and had to be lifted precisely onto the hull and aligned with the turret ring. Traditional manufacturers used overhead cranes operated by experienced riggers who could position the turret correctly. Ford designed an automated turret installation system. The turret was lifted by a specialized crane equipped with alignment guides. As the turret descended onto the hull, the guides ensured perfect positioning with the turret ring. What had required skilled crane operators and multiple workers to guide the turret now required one operator running the automated system. Installation time dropped from 20 minutes to 5 minutes. Similar improvements happened across every assembly operation. Track installation had been a bottleneck. The Sherman's tracks consisted of 79 individual track links per side, each weighing approximately 40 pounds. Traditional methods involved workers manually connecting each link, installing pins, ensuring proper tension. It was exhausting work that took hours. Ford designed track assembly fixtures. The track links were laid out on a specialized table where workers connected them in a controlled sequence. When assembly was complete, the entire track was lifted by an overhead crane and installed on the hull in one operation. Track installation time dropped from hours to minutes. The workers were less exhausted. The tracks were assembled more consistently. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Quality control was relentless. Every weld was inspected. Every bolt was torqued to specification. Every system was tested. Tanks that failed any inspection were pulled from the line, corrected and retested. Ford's quality rejection rate was actually higher than traditional manufacturers, not because their tanks were worse, but because their inspection standards were more demanding. A tank that passed Ford's quality control would survive combat. That was the standard. The workforce expanded rapidly. By summer 1943, more than 4,000 workers were employed at the Highland Park tank plant. Many were women. The same social transformation that had brought women into bomber production brought them into tank production. Women worked as welders, as machinists, as inspectors, as assembly workers. They learned skills they'd never imagined learning before the war. Rose Bonavita became one of the plant's most famous workers, though her fame came from her work at the Eastern Aircraft Division in New Jersey, where she and another woman riveted together a Grumman Avenger torpedo bomber in record time. But thousands of women at Highland Park performed equally demanding work with less publicity. They operated turret lathes that machined gun mount components. They ran milling machines that created precision gears for transmissions. They inspected armor welds using techniques that required understanding metallurgy and weld quality standards. The work wasn't easy. Tank manufacturing required heavy lifting, exposure to welding fumes, constant noise from machinery, summer heat that turned the factory into an oven. But the pay was good. The work was important. The women knew that every tank they built might save American lives. That knowledge drove quality. Every weld mattered. Every gear mattered. Bad work meant someone's brother or son might die in combat. Good work meant that crew might survive. By autumn 1943, Highland Park was producing more than 500 M4A3 Shermans per month, more than Lima locomotive, more than pressed steel car, more than any other single manufacturer. And Ford wasn't finished improving. Engineers continued refining processes, eliminating bottlenecks, increasing efficiency. The goal remained 1 tank per hour, 720 tanks per month. In December 1943, production reached 623 tanks. In January 1944, production hit 703. Ford had achieved what ordnance experts said was impossible. Automotive mass production methods were building tanks faster than traditional armor manufacturers. The assembly line that shouldn't work was outproducing everyone. But the real story wasn't just production numbers. The real story was what those tanks meant to the crews who fought in them. The morning of June 6, 1944, Staff Sergeant William McConaughey sat in the driver's seat of his M4A3 Sherman tank aboard landing ship Tank 338, watching the coast of Normandy appear through the pre-dawn darkness. McConaughey was 22 years old, from Pittsburgh, Pennsylvania. He'd been trained at Fort Knox, Kentucky, assigned to Company C, 70th Tank Battalion, 1st Infantry Division. His tank had been built at Ford's Highland Park plant in February 1944. He'd received it in England in April, trained with it for 6 weeks, learned its sounds, its handling characteristics, the way it responded to his controls. Now, he was about to drive it into combat. The landing craft's bow ramp dropped at 06:30 hours. McConaughey started the engine, a Ford GAA V8 that had been designed specifically for the M4A3 variant. The engine was Ford's contribution beyond just assembling tanks, while other Sherman variants used radial aircraft engines or General Motors diesel engines. The M4A3 used Ford's purpose-built tank engine, 500 gross horsepower, liquid-cooled, designed for reliability under combat conditions. McConaughey shifted into gear and drove the 30-ton tank down the ramp into 4 feet of water. The Sherman was waterproofed for the landing, exhaust extensions rising above the turret, air intakes sealed. The tank wallowed through the surf, tracks churning sand and water, engine roaring. Artillery shells were exploding on the beach. Machine gun fire was hitting the water around the landing craft. German defensive positions on the bluffs above Omaha Beach were firing everything they had at the invasion force. McConaughey drove toward the beach, felt the tracks bite solid ground, felt the tank surge forward out of the water. The waterproofing had worked. The engine was running smoothly. The transmission was functioning. Every system that Ford workers had installed 6 months earlier in Michigan was operating exactly as designed under the worst possible conditions. McConaughey had no idea that his tank represented a fundamental transformation in how industrial nations fought wars. He just knew it worked. The 70th Tank Battalion landed 16 M4 Shermans on Omaha Beach that morning. 15 made it through the surf. 1 drowned when it drove into a shell crater in deep water, and the engine flooded. The 15 that made it to the beach immediately came under fire from German anti-tank guns positioned in concrete bunkers. The German guns were 75mm and 88mm weapons designed specifically to destroy tanks. They could penetrate Sherman armor at ranges exceeding 1,000 yards. The Shermans couldn't penetrate the concrete bunkers at any range. Their 75mm guns could damage the bunkers, could suppress the defenders, but couldn't destroy fortified positions. That wasn't what they were designed to do. The Sherman's job was to support the infantry, to provide mobile firepower, to keep moving inland. McConaughey's tank took 3 hits from German anti-tank guns before reaching the seawall. All 3 rounds deflected off the frontal armor. The armor welds that Ford's automated welding systems had created held perfectly. By nightfall, on June 6th, the 70th Tank Battalion had lost 4 tanks to enemy fire. 11 were still operational. Those 11 tanks had helped American infantry push off the beach, had suppressed German defensive positions, had provided the mobile firepower that let infantry advance when they otherwise would have been pinned down. Without the tanks, the infantry would have taken higher casualties, might not have secured the beachhead. With the tanks, the advance continued. The 70th Tank Battalion's experience was replicated across every American armored unit landing in Normandy. The 701st Tank Battalion landed 29 M4 Shermans. The 743rd Tank Battalion landed 48. The British and Canadian forces landed with their own Sherman variants, many of them built by Fisher Body Division in the United States, some built in Canada. By the end of June 6th, hundreds of Sherman tanks were ashore in Normandy, and behind them, thousands more were waiting in England, waiting to cross the Channel, waiting to replace losses. In Highland Park, Michigan, the assembly line continued operating, 24 hours per day, 7 days per week. Workers who would never see Normandy were building the tanks that would liberate France. They welded armor that would stop German anti-tank rounds. They installed transmissions that would operate through French hedgerows and German forests. They assembled suspensions that would carry crews across hundreds of miles of combat operations. The connection between factory and battlefield was immediate and direct. A tank completed at Highland Park in June would be shipped to an East Coast port, loaded onto a transport ship, delivered to England, issued to a replacement company, assigned to a combat unit, and driven into action in France within 6 weeks. The production-to-combat pipeline was that fast. American industry wasn't just supplying the war. American industry was fighting the war, one assembly line at a time. By mid-1944, Highland Park was producing at rates that seemed impossible 2 years earlier. In June, production reached 894 tanks. In July, production hit 1,012. In August, production peaked at 1,690 tanks in a single month, 1,690 M4A3 Sherman tanks built by one plant in 31 days, more than 50 tanks per day, more than 2 tanks per hour. The assembly line that Army Ordnance said wouldn't work was producing at rates that exceeded every prediction. Charles Sorensen's vision had become reality. Mass production worked for anything humans could design. Bombers, tanks, whatever the military needed, American industry could build at automotive production rates. The implications were staggering. Germany couldn't match this production. Neither could Japan. Neither could Britain or the Soviet Union. Only the United States had the industrial base, the engineering expertise, and the willingness to apply mass production principles to military equipment. The German military was beginning to understand what they were facing. Intelligence reports from the Eastern Front described Soviet tank production rates that seemed impossible. The Soviets were fielding T-34 tanks in quantities that overwhelmed German defensive positions through sheer numbers. American Lend-Lease Sherman tanks were arriving in the Soviet Union by the thousands, supplementing Soviet production. On the Western Front, German commanders were discovering that destroying American tanks didn't stop American tank attacks. Every Sherman knocked out was replaced within days by 2 more. A captured German report from July 1944 analyzed American tank tactics in Normandy. The report noted that American armored units attacked with wasteful disregard for losses because they knew replacement tanks would arrive immediately. German units couldn't operate that way. Every Panzer lost was a significant reduction in combat power, because replacements took months to arrive. German tank production in 1944 was running at approximately 1,500 tanks per month across all types: Panzers, Panthers, Tigers, assault guns, tank destroyers. The United States was producing more than 2,000 Sherman tanks per month from multiple manufacturers. Highland Park alone was producing more Shermans than Germany was producing Panthers and Tigers combined, and that didn't account for American production of tank destroyers, light tanks, or the thousands of other armored vehicles American industry was building. The mathematics of industrial warfare were brutal. Germany was fighting enemies who could replace losses faster than German forces could inflict them. The quality of American tanks versus German tanks was a subject of endless debate then and remains controversial now. The German Panther tank mounted a 75mm high-velocity gun that could destroy a Sherman at ranges exceeding 2,000 yards. The Sherman's 75mm gun could only penetrate a Panther's frontal armor at ranges under 500 yards. In a one-on-one engagement at long range, the Panther had overwhelming advantages. But war wasn't fought as one-on-one duels at long range. War was fought with whatever forces you could bring to the battlefield and keep supplied under combat conditions. A Panther was a superior tank if you had fuel for it, if you had spare parts, if you had trained crew, if you had ammunition, if you had recovery vehicles to tow it when it broke down. German forces in France, in summer 1944, often lacked all of those things. Shermans were simpler, more reliable, easier to repair. The Ford GAA engine in the M4A3 was particularly reliable. It was a liquid-cooled automotive engine, not a repurposed aircraft engine. It had been designed from the beginning to power a tank under combat conditions. It was easy to maintain. Parts were standardized. Any Ford-built M4A3 had the exact same engine as every other Ford-built M4A3. Mechanics could swap engines in the field if necessary. The transmissions were similarly standardized. The suspensions were identical. Everything was interchangeable. German tanks didn't have that advantage. Different manufacturers built tanks with different components. A Panther built by MAN used different parts than a Panther built by Daimler-Benz. Spare parts weren't always interchangeable. Field maintenance was complicated. Recovery and repair took longer. And most critically, German tank production couldn't match losses. A German armored division that lost 20 Panthers in combat might receive 5 replacement tanks in the following month. An American armored division that lost 20 Shermans would receive 30 replacements the same week. This disparity shaped every tactical decision. German commanders hoarded their armor, used it carefully, avoided unnecessary risks, because every loss was semi-permanent. American commanders used armor aggressively, accepted losses, relied on the production system to replace whatever was destroyed. The American approach wasn't reckless. It was realistic. They understood that industrial warfare favored whoever could sustain losses and continue operations. The crews who fought in Shermans understood the trade-offs. The Sherman wasn't invulnerable. German anti-tank guns could destroy it. Panzerfausts could destroy it. Mines could destroy it. A well-positioned German tank could destroy it. But the Sherman was reliable. It started every morning. It kept running under difficult conditions. It could be repaired in the field. And if it was destroyed, another one would arrive to replace it. Sergeant Lafayette Poole commanded an M4A3 Sherman named In the Mood with the 3rd Armored Division. Between June and September 1944, Poole's crew destroyed more than 12 German tanks, multiple anti-tank guns, countless soft-skinned vehicles. Poole survived the war, despite his tank being hit multiple times. He understood the Sherman's limitations, but also understood its strengths: speed, reliability, the certainty that if his tank was destroyed, he would get another one. By autumn 1944, the material superiority of American armor wasn't about individual tank quality. It was about the system. Training, logistics, maintenance, above all, production. Highland Park was producing more than 1,000 tanks per month. Other American manufacturers were producing thousands more. The combined Sherman production from all sources in 1944 exceeded 17,000 tanks. Germany produced approximately 19,000 tanks and assault guns of all types in 1944, but Germany was fighting on multiple fronts: the Soviet Union, Italy, France, the Balkans. German armor was dispersed across multiple theaters. The United States could concentrate armor wherever needed, because production could replace whatever was committed to combat. This industrial advantage became psychological warfare. German tank crews who destroyed 3 Shermans in an engagement would watch 5 more Shermans arrive the next day. They were winning tactical battles and losing the strategic war because American production made tactical victories meaningless. Destroy 10 American tanks and 20 would arrive as replacements. Destroy 20 and 40 would arrive. The Germans called it the tyranny of numbers. No matter how skilled their crews, how superior their equipment in individual engagements, they couldn't overcome the fundamental mathematics. American industry was producing faster than German forces could destroy. The breaking point came in different ways across different sectors of the front. In Normandy, it came during Operation Cobra in late July 1944. American forces concentrated armor for a massive breakthrough operation. German forces fought desperately to contain the breakthrough, committed their armor reserves, achieved local successes, then watched American armor keep coming. Waves of Shermans advancing despite losses, new tanks replacing destroyed tanks within hours. The German armor was ground down through attrition, not defeated in single dramatic battles, but worn away by continuous combat against enemies who had inexhaustible replacements. By August, German forces in Normandy were shattered. The survivors retreated toward Germany, abandoning equipment they couldn't fuel or repair, fighting delaying actions with whatever remained. American armor pursued across fronts, the same pursuit that created the logistics crisis that led to the Red Ball Express. But the armor kept moving because tanks kept arriving. Highland Park continued producing. Other American manufacturers continued producing. The replacement pipeline never stopped flowing. In September 1944, American armored divisions reached the German border. They paused not because German defenses stopped them, but because fuel supplies ran out. When fuel arrived, they started moving again. The German military tried to understand what they were facing. Intelligence officers analyzed American production capabilities, calculated industrial capacity, estimated monthly output. The numbers were horrifying. The United States was producing more tanks, more aircraft, more artillery, more ammunition, more of everything than Germany could match. And unlike German production, which was being disrupted by bombing, American production was completely safe. No enemy bombers threatened Detroit. No enemy artillery threatened Highland Park. American workers built tanks in perfect safety, shipped them across an ocean that American naval forces controlled, landed them in France, where American logistics kept them supplied. The entire system, from factory to battlefield, operated with industrial efficiency that Germany couldn't disrupt. Some German commanders understood this meant the war was lost. Not lost because of any single battle or campaign. Lost because industrial capacity determined outcomes in mechanized warfare, and Germany didn't have the industrial capacity to compete. Others believed superior tactics, superior weapons, superior training could overcome numerical disadvantages. They were wrong. Superior tactics work when you can maintain the initiative. Superior weapons work when you can supply them adequately. Superior training works when you can replace trained personnel losses. Germany couldn't do any of those things by late 1944. American production had created a military machine that could absorb defeats, replace losses, and continue offensive operations indefinitely. The human cost of this industrial warfare was immense. On both sides, American tank crews died in burning Shermans. German tank crews died in their supposedly superior Panthers and Tigers. Infantry on both sides died in battles where armor clashed. Civilians died in cities destroyed by fighting. The victory that American production made possible came at enormous cost, but the production system ensured that cost didn't lead to defeat. Every loss was replaced. Every defeat was temporary. The industrial base kept feeding the war machine. At Highland Park, workers never saw the results of their labor. They didn't watch Shermans land on Normandy beaches. They didn't see tank crews fighting across France. They didn't know which specific tanks were destroyed and which survived. They just kept building, welding armor, installing engines, assembling suspensions, testing transmissions. Every shift, every day, every week, another batch of tanks rolled off the assembly line and into the war. Some workers had relatives in armored units. They knew that somewhere in France or Germany or Italy, their brother or cousin or son might be fighting in a tank they'd helped build. That knowledge made the work personal. Every weld had to be perfect because someone's brother was depending on it. Every transmission had to be reliable because someone's son needed it to work under combat conditions. The connection between factory and battlefield was intimate, even though most workers would never see a battlefield. Production continued through 1945, even as Allied forces advanced deeper into Germany. Even as German resistance collapsed, Highland Park kept building tanks. In January 1945, production reached 1,200 tanks. In February, 1,400. The numbers remained high because the Army couldn't predict when the war would end. They planned for every contingency, including the possibility that Germany would fight into summer 1945. The war in Europe ended May 8, 1945. Germany surrendered unconditionally. The fighting stopped. American armored units that had crossed France, Belgium, and Germany parked their tanks and waited for orders. Many of those tanks had been built at Highland Park. They'd survived combat, proved their reliability, brought their crews through the war. At Highland Park, production wound down rapidly. The Army cancelled remaining contracts. Tank orders were reduced, then eliminated. By June 1945, production had stopped completely. The final M4A3 Sherman left the Highland Park assembly line on June 30, 1945. Workers gathered to watch it roll off the line. The last of more than 15,000 tanks built at that one facility in less than 3 years. From October 1942 to June 1945, Highland Park had produced 15,055 M4A3 Sherman tanks, more than any other single tank manufacturing facility in the war, more than German production of Panthers and Tigers combined. The achievement was staggering. A plant that hadn't existed in early 1942 had become the most productive tank facility in world history, using methods that armor experts said wouldn't work, employing workers who'd never built tanks before, producing at rates that traditional manufacturers said were impossible. Charles Sorensen's vision had proven correct again. Mass production worked for anything: bombers at Willow Run, tanks at Highland Park. The principles were identical: standardize components, create specialized tooling, train workers for specific operations, move the product through sequential workstations, inspect everything, test everything, build more than enemies can destroy. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.